Alrighty, problem 5, doing some graphing. Again, with any graphing problem, it's always going to be super helpful to just think of it in terms of, well, what does the graph of the mother function look like, and then what are my transformations? So rather than jumping straight to this cosecant graph, I'm going to ask myself, well, what does y equals negative 3 sine of 4x look like? What's that going to look like? Because that'll tell me what cosecant looks like, because cosecant is just going to be the reciprocal of this. So start thinking about it. First off, thinking about like the most basic sine graph ever, y equals sine x. That's going to start at 0 and look like that. And that's going to have a period of 2 pi. It's going to have an amplitude of 1. And there's no phase shift or anything, so we're good there. Now just think about what these transformations are going to do. Well, first off, that negative 3 coefficient, that's going to flip everything. So now it's going to look like that red guy because of the negativeness of the coefficient. Well, and then the 3 also, that's going to make it so that those max and mins right there are at negative 3 and 3. Sorry, you can't see that. 3. So that's that. And then what else is there? That 4x, what does that do? Well, that's going to modify my period. So that's going to take my period from 2 pi, and it's going to make it 2 pi over 4, which is pi over 2. So now that's like saying, well, that point right there is pi over 2. So you can start with all that, and then if I want to get to cosecant from there, all you got to do is just flip it. Bam. So let's look at a big version of what this is going to look like. So let's again just go through those pieces that I did there. We'll look at it one more time, and I'll show you how I would actually graph this without even needing to graph the sine stuff. So starting off, again, I'm going to identify my period. Normal period of a sine graph or a cosecant graph is 2 pi. So to get our modified period, we take 2 pi and divide it by that coefficient, that 4, to get pi over 2. So I'm going to start simply by putting a pi over 2 over here. This is always what I do. I start by putting my wherever my period is going to end, so pi over 2, and then I just start splitting this into halves. So that's going to be pi over 4, that's going to be pi over 8, and that's going to be pi over 8, 3 pi over 8. I do that because I really think that these trig functions are so much easier to understand if you can think about it in terms of fractions. And so again, think about these functions. Well, where is sine of theta going to equal 0? Because that's going to tell me where cosecant is going to have a vertical asymptote. Well, I know it's going to be 0 there, because sine of 0 is 0. And I know my period is pi over 2, so I also have to have a 0 there. And I know that halfway between those 2 points, I'm also going to have a 0, because at this point, right up there. Okay, so now I can use that to sketch in asymptotes. Because remember, cosecant is 1 over sine, so we're going to have 1 over 0 is undefined. And then again, to start splitting it up. Well, halfway between your zeros, you're going to have either a max or a min on sine, which is actually going to also be a max or a min on cosecant. It's going to flip though. So again, think about that 3. That 3 has moved this boom, 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 boom. And now you just got to think, well, is it going to be positive or negative? Well, I know since my coefficient is a negative 3, it's going to flip everything. Normally sine starts positive, but this time it's going to go negative since we flipped it. So I'm going to get this point right there. Pi over 8, comma, negative 3. Similarly, I'm going to get this point right here. Last part, just sketch in your graphs. And you're done. And it only wants you to show one period and that's one period. So we're done.